Okay, so here we have, I guess Arduino 9, part 1. Here's our just kind of initial variables, or inputs. Let's see, we have our analog input for the thermistor, which is A10 or pin A10. Our resistance, or our other resistor is 10,000. And then these are just inputs to allow variables to be, I guess, values to be added to these later on that we define in our calc temperature thermistor function or in our value of the thermistor up here. Our setup, we're just saying that our, I believe, analog input thermistor, that is an input, not an output. And then here's our refresh rate, matches over here to the right. And then our loop is it takes the value of the thermistor by reading the input of the analog input thermistor, and then it goes into the calc temp thermistor function. And then we have a delay of 3 seconds. You can see we have the program running now. 1, 2, 3, 1 Mississippi, 2 Mississippi, 3 Mississippi. So we run every 3 seconds, and then, the loop goes, or is completed every 3 seconds. And then our void temp, or calc temp thermistor function, our voltage out is, we use this equation here because the value of the input is between 0 and 1023, and we're running 5 volts. Then we're able to calculate the resistance of the thermistor out using this equation here. And then we get this equation, which is a little different. We take that from Excel. If this is my initial, I actually switched. So this graph here is from taking, this is temp on the x-axis and then resistance on the y-axis. And just comparing that to what it should be, we're looking to get temperature out of our equation. This would give us resistance. So I switched it up. Here we have resistance on the x-axis, on the x-axis, because that is what we are measuring through the input. And here we have the temperature, or the output temp, and this gives us, when we do the curve fit, negative 28.98 times the natural log of the resistance plus 291.37, and that is our basic equation that can be used to calculate Celsius. So we get the output, R underscore thermistor, and then it gives us our temperature in Celsius, and then we can convert that to Fahrenheit. This very simple equation, but I did run into problems somehow making sure the logic worked or ran in the right order. So this is just what seemed to work for me. I'd get a weird, a semi-accurate Celsius temp, and then the Fahrenheit temp would just be completely off relative to it, or vice versa. And here we have our output. Added a little space just to make it read a little bit better. And here we have our board. We have our 5 volts, our ground, which is the black wire, and then we have our input as well. And so we have the input, so we know the voltage going into the thermistor, and then we know that the voltage then drops. And here we have a 10K ohm resistor as well. And all in all, after all calculations, we get, you can see the little touch there. If I touch thermistor, you're going to see this temperature going up in Fahrenheit. See, we're going up to 70 degrees, 72, 73. And so baseline, if we go back up to the top, my apartment thermostat is currently reading 62 degrees at the moment. We don't have the heat running. We keep it fairly cold. And yeah, so that to me is an accurate reading and it responds in the correct way, so that is how I know that it is working. Okay, so here we have part 2 or part B to Arduino number 9. Here we have all of our variables defined, very similar to the last, or part A. As you can see on the board here, nothing changed, or at least I didn't change anything on this end, and we really just built off the code and we added the potentiometer here. So still the 10K resistor, the thermistor, and here we have our 3-prong potentiometer, which I'll show changes everything. Our 5 volts going in, and then our voltages still going across everything here. So here we have our setup. We also have to make sure to have the potentiometer as an input as well. Our LED pin is also an output. Then our LED pin is 13. Our analog input for the potentiometer is analog 11. And for a loop, we get the value of the thermistor, analog read, the pin of the thermistor, then we can calculate the temperature of the thermistor there with our same function from part A. And then we get the value of the potentiometer, analog read, the input pin A11, and then we use our calc temperature potentiometer function. And then we have a if-else statement here. If the temperature of Celsius in Celsius of the thermistor is less than the T set, which down here we will define T set, that is the value of the potentiometer, then the LED pin will turn on, which, yes. So, and then we'll also get printed out to the serial monitor here. So as you can see, everything's running every 3 seconds with that delay. And if the value of the thermistor in Celsius is greater than the temperature set, then the pin will be off, which you can currently see now. The light that's blinking is just showing that the delay is happening. So here you can see the refresh. Our thermistor is recording 61 degrees Fahrenheit, which is about 16.5 Celsius. Our set temp is at 10. If we take this, you can turn it up a little bit, and our set temp is now at 53 Celsius. So since the temperature is lower, as you can see here, this LED is on all the time. So, and you see the temp 53 Celsius, and we're still reading 15.5, even if I put on or increase the temp. There we got 21.45, 30, 91. Yeah, see, you still won't go above that. So that LED will stay on. And then, and showed all this in the last video. And then for our calculations of the temperature of the potentiometer, we take the V out, or the voltage out. That gives us a number between 0 and 1023. And using the map functions, the temperature set will then be based off of the voltage out as well. So if it's at 0, see there, then it will be 10. So if it's turned, I believe, all the way to the right, it will be 10, at least how I've set it up. If it's turned all the way to the left, we get a value of 1023. We'll get a value of 80. And then we just print that out, what the temperature is set at. And then we print it out, gives us a little bit of space, or puts it on a new line. believe the serial print ln is just so that we have a space in between all of them, so we can determine and look at separate runs, I guess. And then the delay is just that it will run every 3 seconds.